All right, we actually don't have much left in 310, but we do have a couple of more challenging problems here. So let's look at example 5. I believe that's what we're ready for. And we have our nice domain. We like this because when you have that, you don't have to do the plus or minus 2 pi n stuff. This is just going to be it. And we want 2 sine squared plus sine to be less than 0. All right, now we solved some of these last time that were equals. So you know exactly how to start. What are we going to do to start? We're going to have to factor out a sine. So we have sine, and then we'll be left with what? 2 sine plus 1. Now, you need to be really, really careful here. In an inequality, you don't just jump to sine less than 0 and 2 sine plus 1 less than 0. That works in an equation, but not in an inequality. And here is why. Make this make sense in your head, all right? Think about this. Are these two things being multiplied together? Yes. And the answer, after I multiply them, is less than 0, which means negative, right? Can they both be negative and make that happen? What, negative times negative, is that going to be negative? No. What has to happen in this problem? You have to have one of them be positive and one of them be negative. So, my next step, well, I can go ahead and solve that. This is going to be sine equals 0, and this is going to be sine equals negative 1/2 if I go ahead and solve them. Now, one of them has to be positive, and one of them has to be negative in order for this to happen. So, let's say this sine will make that one positive, and we'll make this one negative. Okay, does that make sense? But it could also be, so I'll put a big or here. The first one could be negative, and the second one is positive. Yep.
Well, but couldn't it be like negative 1/4 for the second one? Like, for those, on the second example, the second sine, when you're saying sine theta is greater than negative 1/2, couldn't it be negative 1/4? Could that be an option?
Wait, these are my key numbers I have to be using. These are going to be like the dots on my number line. So when I solve this, then I get negative 1/2.
Yeah.
Yeah. Now, we're going to have lots and lots of different answers, and we're going to have intervals of answers. But these are the key numbers, and these will give me my key angles. Because remember, our answer is going to be angles.
I thought you couldn't do any simplify or solve it because it's an inequality. So how'd you get the negative 1/2 to 0? Because I thought that you didn't know, so you couldn't solve it if either one was negative or positive.
Well, I don't know which. I know one's negative and one's positive. I don't know which is which, so that's why I have two cases. So I have the first positive, second negative, and then I have first negative and second positive. It has to be one of those. Those are the only options.
And are the theta are those each different angles or are they the same?
They're going to be my possible answers to the question.
Okay.
So it's like when you do if you have x plus 3, x minus 4, less than 0. Your key numbers here are negative 3 and 4, right?
Yeah.
You either have to have this one has to be less than 0, and this one's greater than 0, or the other way around. That's what I'm doing here. I just have sine theta instead of x.
Okay.
How can that one work? Because couldn't they both be negative on that one? Like the second one could just be negative 1/4, and then it would just be negative.
Okay,
negative.
why don't we just go ahead and solve it and see what happens,
All right.
okay? So right now, we are considering where the product of these two things is going to be negative. And I hope we've figured out that if the product is negative, then one of them is positive and the other one's negative. I don't know which way it goes. So there I have the positive, negative. Here I have the negative, positive. All right. Now, let's see what this looks like. I can do this on my unit circle, or I can do it with a sine curve. Which way do you want to do it? Unit circle. All right. So I'm doing this case right here. So here's my unit circle. And I have to have the sine be bigger than 0. Now remember, sine is equal to 0 here and here. Would everybody agree with that? Not that way. Would everybody agree with sine is equal to 0 at those two places? These are all going to be open circles in the problem because there's no or equal to. So I'm going to open that up, and it's a sine. I'm looking at sines, so I need to look at y's. I need to look at horizontal lines. So here's my horizontal line, and I want to be, for this case right here, I want to be bigger than that. So that means I am looking at all of this part of the circle. And that should make sense to you. If you want your sine to be positive, don't you have to be in quadrant 1 or 2? Now, where does the sine equal negative 1/2? Remember, sine, that's your y value. Where is it negative 1/2? Well, what kind of angle is it, first of all? If the y is 1/2, that is a pi over 6. But since it's a negative, it would be here or here, wouldn't it? So 7 pi over 6 and 11 pi over 6. Again, open dots. It's a sine value, y, sine, and this time I am looking below that. Is it possible to have angles where the sine is positive and the sine is also less than negative 1/2? Is that possible? No, because look what happened. Did I get any overlap? And means you gotta have overlap. And I didn't get any. So this isn't possible. All right, let's look at this one. Now the good news is the angles are going to be the same, right? Switching the signs doesn't change that. The angles will be the same. So I have 7 pi over 6 and 11 pi over 6. Okay. This time I want to be less than 0. So I'm going to use my pink marker. And would you agree that this right here is my pink? Okay, that's where I'm less than 0 this time. But now I also have to be bigger than negative 1/2. Well, here's where we are negative 1/2. Here's my line. So doesn't bigger than mean all of this? So what are the answers? The answers are everything that's pink and blue. Remember, when you write your answer, you start here and go this direction. Okay? So what's the first shading starts at pi and ends at 7 pi over 6. And the next shading starts at 11 pi over 6 and ends at 2 pi. Alex?
But wouldn't you be multiplying two numbers together? So wouldn't that mean, or multiplying two negative numbers together? So wouldn't that make it a positive number?
Okay, so here's what I want you to do. Take out your calculator and let's pick a number. We're gonna plug it in here. We're gonna plug it in that equation. Okay? So let's pick a number like in between here. Is that all right? So that's 180, that's 210. Put your calculator in degrees, and let's just do 200. Because 200 degrees would be in between those two. All right, so put 200 degrees in here. Now, we didn't talk about this yesterday. If you're gonna put this into your calculator, 2 times the sine of 200 squared. We write it this way, but your calculator can't accommodate that, so you have to type it in this way. Put parentheses, sine 200, close parentheses, and square it. And then plus sine 200. And tell me if you get what kind of a number you get. I'm hoping you get a negative number.
I got negative 0.1.
There you go. And that was our goal. Our goal was to get a negative result when we put it in. Okay, so Alex, remember, you need, these are the two things that we need, one to be positive and one to be negative. So apparently in this interval right here, sine theta is going to be negative, but 2 sine plus 1 is positive, okay? We're not saying sine is positive, we're saying 2 sine plus 1 is positive. Does that make sense to you? All right, any other questions? I'm gonna have to erase it to do the next one. It's a lot, for sure. All right, so we're good here? All right, let's look at the next one. Okay, now this one's a little bit different. What do you think is going to be your first step to that last problem?
Add the 1.
Look at it carefully. What kind of equation is that? Isn't that a quadratic? And I want my quadratics, just like the one I just erased, I want my quadratics to be set equal to 0, because what is my fervent hope? If I have a quadratic, I'm hoping that I can factor it, which is exactly what I just did with this one. But this factoring is going to be a little bit more involved, because it has this third term here, it has this minus 1. So we're gonna factor it like this, guys. Take a look at it closely. I'm gonna make that equals to start with. Get it set equal to 0, now I'm gonna factor it. Do you see a trinomial in there? A trinomial that's built just like that. 2 times something squared, minus, or excuse me, plus that thing, minus 1. So how would we factor that? Forget all this. How would I factor that right there? How's that factor? Don't make me crazy, people. How do we factor it? 2x and x, 1 and 1,
Minus on these ends.
plus and minus like that. Foil it. That's a positive 2x, that's a minus 1x. What do I want? Don't be lazy. FOIL your answer back and make sure that you got it factored correctly. So, if that one factors like that, how is this one gonna factor? It's the same thing. It's gonna be 2 cosine minus 1 and cosine plus 1. So my key angles, the angles that are gonna show up in my answer are going to be where the cosine is a half and where the cosine is negative 1. So let's just go ahead and find those angles right now. This one's pretty easy. Where is the cosine negative 1? Pi? Everybody okay with that? X is negative 1. Now where is the cosine 1/2? I hear some answers already. If the cosine's 1/2, that's going to be pi over 3, I heard somebody say. And then where else? 5 pi over 3. Is everybody okay with those two angles? For this one, where pi over 3 and 5 pi over 3, where the cosine is positive 1/2? Well, this time, these two things multiplied together have to be greater than or equal to 0. So how does that happen? How do you multiply two things and come out positive?
Positive.
Both positive, so cosine bigger than 1/2 or equal to, bigger than or equal to 1/2, and cosine bigger than or equal to negative 1, or cosine less than or equal to 1/2, and cosine less than or equal to negative 1. Everybody okay with that this time? Before we had 1 positive, 1 negative, because we wanted to be negative. Now we want to be positive, so we have both positive and both negative. Okay, well, I've already got my circle started here, so I'm going to do this case right here on this circle. And then over here's pi. So if I want the cosine here, cosine now is an x value. So I got a vertical line. And I want to be bigger than 1/2. So that means I want to be over here. Would you agree with that? I also want to be bigger than negative 1. Isn't the whole circle bigger than negative 1? So the whole thing's going to be blue. Everything is to the right of that point. So what's my answer? Where's the overlap? I've got some. We start here and go this way. So what's shaded? Well, is 0 shaded?
Yep.
All right, so I'll start with 0. And then I'm going to shade all the way till I get to pi over 3. And then I'm going to keep going. No more shading, no more shading, no more shade. Whoops, it starts back up here. And it goes all the way to 2 pi. And I need to check my directions. Is 2 pi included? Yes. So that's gonna be the answer to the first part. You okay with that? All right, so now I have to do the second part. So the angles haven't changed, so I'm still gonna have pi over 3 and 5 pi over 3 and pi. Those are my angles in this problem. this time, I'm doing this one. This time, I want to be less than half. So where am I going to shade? I want to be less than a half, so it's going to be left. So that's all of this is shaded. And then I want to be less than -1. What's shaded? Nothing. Now, -1 is included, pi is included, but there's no extra shading. Okay? So, do I have any overlap there at all? Just pi. So, yep. So your answer is all that right there.
So we have to check both each time.
Yes. Yes. And remember, that is an or. So, I mean, this is an or.
Yeah, okay.
So you're gonna put these answers together with these answers, once you get your final answer. Oopsie, it's a lot. It's a lot. All right, let's turn to page 13. And let's look at the check your understanding. Now, I know we just got done doing an inequality. These are not inequalities. Okay? So, kind of put this like out of your mind for a minute and do these equations. All right, so page 13 front, page front, or 13 front, let's do it. And yes, indeed, help each other. You will definitely need a calculator for number 2.
That's it.
2 is not. 3 is. 2 is not. And you need 1 and 4 also. So 2 and 4, you can calculate for at least 4B. Okay, how is our understanding coming?
Not good.
All right, did we understand the first one?
Yeah.
What did we get for the first problem? Enzo got pi
That's what I get.
for the first one. So what are the rest of us? Number 1, pi. Everybody okay with that? All right, number 2, we need a calculator. Now, we talked about this a bit yesterday, but our calculator is only ever going to give us one answer. It's going to give us the arc sine or arc tangent or whatever answer. It is up to you to figure out if there are other answers. So when I look at problem 2, it says I gotta go all the way around the unit circle, so 0 to 2 pi, and I gotta find all the places where the sine is 0.75. Right? Okay. Well, where does that happen? Where does the sine equal a positive number? Quadrant 1 and 2. So whatever my angles are, one of them is in quadrant 1, and one of them is over here in quadrant 2. Would you agree with that? Now the calculator will tell me how big that angle is right there. So second sine 0.75, inverse sine, I got 0.848. Now, all of the angles with that sign down, just like your unit circle, like how all the pi over 3's have the same ordered pair. Well, this is going to be the same thing. This angle right here is still going to be 0.848. But now, what is that angle? This one was 0.848. How would I find this angle, the one in the second quadrant? Pi minus 0.848? Isn't this pi? So wouldn't that guy right there be pi minus 0.848? Let me get my answer here, Alex. So I got 2.294. Alright, Alex, yes?
But you also just add pi over 2 to 8 to 0.848 because that's moving it.
Okay, be careful though, is if you're gonna add pi over 2, then your assumption is that angle right there is the same as this angle right here.
Would that only work if they were 45 degrees?
Yeah. Try it, Alex, and see, and maybe that will convince you. If you take 0.848 and add pi divided by 2, you don't get the same answer. Because pi over 2, this is not the angle that's 0.848. If this angle were 0.848, this one right here, you could add pi over 2 to get that, but it's not, it's the inside one. So it's gonna be pi minus 0.848. Another way to think about that, Alex, is, see this angle right here, this bigger angle? That angle is formed by these two lines, right, where my fingers are. Pi over 2 is not involved in that discussion. Pi over 2 is here. My fingers are forming that angle, so I'm gonna use pi 0.848.
Is that marker on your hand?
Huh?
Is that marker on your hand?
Oh, yeah. I look like I'm in a coal mine.
Yeah, I didn't know.
Yep. Okay. Now, how did you do with number 3? Did you get that one okay?
Owen did it.
Owen got it?
Yeah.
What did you get, Owen, as your answers?
Pi over 3, 2 pi over 3, 4 pi over 2, 5 pi over 3.
I think he's right. Don't we just set that equal to 0 if we want to know what the x-intercepts are? And then when he solved it, he got sine squared equals 3/4. So sine equals plus or minus root 3 over 2. Remember, when you square root, it has to be plus or minus. You guys, are you with me here? You got this? Okay? Alright, so where does that happen? Well, Owen said somewhere out here there's an angle that has a y coordinate of root 3 over 2. And that angle is pi over 3. Right? But it's plus or minus, so it's everywhere, which would be all the pi over 3. So pi over 3, 2 pi, 4 pi, 5 pi. Good job, Owen. Did you do it by yourself, or did your team coach you up there?
Cool coach.
No, genuinely it was a
Cool coach and group.
All right.
Emotional support.
Okay, now we're going to skip that last one for a minute. I want everybody to turn to page 15 because we've got to get another inequality done. So let's turn to page 15. And we are going to do problem C, but I'm going to make it an inequality. Okay? So here we go, problem C. We are going to change it into less than 0. And I picked that problem because you have plenty of room to work there, because we know these take plenty of space. So we're going to solve this inequality. All right, so Meredith, what are you going to do first? Try and factor it. Meredith says, I got a quadratic equation. I need to get it set equal to 0. It already is. And then I'm going to try to factor it. What do we do if it doesn't factor? Because in the real world, stuff doesn't factor sometimes. What do we have to do then? Quadratic formula. Absolutely. There's your A, your B, and your C. You would use the quadratic formula. Let's see, does this one factor? No, it sure would be easier if it did. Does this factor? 2 cosine, cosine. minus and minus.
Oh, 4 and 1.
4 and
Oh, wait, no.
What?
No. I forgot about the 2. Shut up.
1 on the
Shut back to
2 cosine x. And
I gotta multiply to get 2, so I need a 2 and a 1.
1 and 2.
So it's gonna be 1 and 2, because when you FOIL,
I'm right, you just didn't see what I saw.
4 and 1
You
was
saw
not
2
right.
times 2.
4 and 1, you add them together, you get -5.
He just saw the 2 times 2.
Yeah.
I got you, Cole.
Alright, so if you don't get that, woe be to you. You need to be able to factor, and you always can check and make sure it works, that it does. Like he said, -4, -1. Alright, so what are gonna be my angles in my problem? I'm gonna have a cosine of 1/2. Uh-oh, a cosine of 2. Can cosine be 2? No. So when I look at my circle, are we gonna do this one on the circle? If we do this one on the circle, cosine 2 would be, x equals 2 would be out here, right?
Solve the circle.
That's where x is 2. Now remember, this is not an equal, I wrote equals, but this isn't really an equals, it's a less than. So I'm gonna be looking, less than 2 would be the whole circle, and bigger than 2 would be nothing. Does that make sense to you? Okay. Now, where does cosine equal 1/2? Pi over 3 and 5 pi over 3. So here's pi over 3, and here's 5 pi over 3. And this is a less than, so I'm gonna put open dots there. Okay, are you with me? All right, so now we gotta set up our problem. Remember, it wasn't an equals, it was a less than. So you are multiplying two things, and you're being negative. So what do we know about the two things? One's positive, so we'll let cosine x be bigger than 1/2, positive. And the other one's negative, we'll let cosine be less than 2. I'm really setting these things bigger than 0 and less than 0, but since I've already solved them, I'm just going ahead and solving them. So this is my positive and my negative. What's the other case? Negative, positive. All right, in a second, you're going to do one of these by yourselves. So is everybody on board here with the setup?
How do you know if it's and or?
Well, between cases, it's always or. And listen to how we described it. You either have to be this one negative and this one positive, or it has to be this one positive and this one negative. I mean, if you just say it, I need negative, positive, negative and positive, or I need positive and negative. If you think about the problem, the words flow naturally. All right, so we already know where the cosine is 1/2. Right there's where the cosine is 1/2. So for case 1, we want to be bigger than that. And we want to be less than 2. Isn't the cosine always less than 2? The whole circle? So the whole circle is shaded and this is shaded. So isn't that my answer to case 1? But again, be careful when you answer it. You have to start at 0 and go that way. So what's shaded is 0 shaded. Yes. That's a bracket. And I'm shading all the way till I get to pi over 3, which is an open dot because of the symbol. Alright, I'm at keep going, keep going, keep going. I'm gonna start again at 5 pi over 3 and shade all the way to 2 pi. And is 2 pi included? No. So I'll put open at 2 pi. Now that's case 1. Has anybody been thinking about case 2 yet? What are you thinking, Declan?
It's not gonna work because
Not gonna work.
nothing's greater than 2.
Nothing's gonna be greater than 2, right? No part of the circle is gonna be greater than 2. That would be out here. Nothing's out there. So that one doesn't have an answer. And therefore that is the answer. Okay? Now, is it possible for the second half of the problem to have an answer? Yes, it is. And you just add it on to the first half. Alright? Now, you are going to do problem D, only make it a greater than or equal to.
D on the same page.
Yeah, same page. D on the same page. Now, do we need more room? Yep, you can do it on the previous page, but I need that one, I need a quadratic. So do D now, by yourselves, with your partner, figure out D. You have been on the totally wrong page, we're right here. Yeah, make it greater than or equal to. Greater than or equal to. So 4 sine squared minus 1, greater than or equal to 0.
Wasn't that probably an and? Wouldn't that make the symbol for the
No, your answer is everything that shaded both colors, okay? So I didn't use a color for this one because it was the whole circle, but here I got black, then I'm shading everything less than, so the whole thing is blue. So everything black and blue is part of the answer. So what are the parts of the answer? Well, it's this little section or this little section.
Then what are the and? Is this like where they're together?
Does this section right here overlap with that section right there? So again, you guys are trying to memorize crap and you have to just think about it. Your answer is everything that's shaded. What is shaded? This little section is shaded. So an answer could come from this little section, or an answer could come from this little section.
Okay.
Where do my answers come from? Well, either this piece or this piece.
So if we were saying, if we wanted to say and, we would just say like where the two come together.
There's no overlap.
No, it makes
between
sense.
the two. That would be empty set. There's no empty set. There's no inner overlap here. So what you would be telling me then is, if you put an intersect here, you'd be telling me there's no answer. And that's wrong. These two do not overlap. There is no and for those two.
I just need more practice.
Yep, you do. Fred, are you guys done already? You are? Alright, you wanna come up and show us your work here? Do you have some kind of coherent work?
Yeah.
Okay, alright.
What are you trying to say?
Rex, please wait a second.
Can you check it before I do?
We'll check it together. I'm sure it's fine. Would you write the problem up the top there, Larry?
Oh yeah, mine's a 0.
Okay, Enzo, you have written nothing down. Alright, so Enzo needs guidance.
I got you.
When we have a quadratic equation, we need to have a set equal to 0, and then what do? Well, how do we solve it? How do we solve a quadratic? What do we have to do? you have to factor it. How does it factor?
Wait, Brett. Why'd you say it's greater than or equal?
That was the problem.
That's the problem.
Oh, she said that.
She changed it from.
Okay, so I'm gonna have to intervene here. Fred, thank you, but we're stopping. Okay, thank you very much. We have an issue. Sit down, we'll talk about the issue. All right, so
That's what I
what it
got, Fred.
is, shh, guys, I want you to listen now, listen. Is this quadratic? Is this quadratic?
Yes.
Okay. Is it set equal to 0? Yeah. What is the next step? Try to factor. You cannot take the square root of both sides of an inequality. Taking the square root is fine if you have an equals. You cannot square root an inequality. So, how does this factor? Leave it just like it is. How does it factor,
2
Gabby?
sine plus.
2 sine x plus 1, and then 2 sine x minus 1.
Exactly.
I'm on the same page.
We are going to factor it as the difference of squares. Okay? So then, my two key numbers are gonna be where sine is -1/2 and where sine is +1/2. Right? So I'm gonna find those angles that are gonna be part of my answer. So, where does the sine, that is the y value, equal 1/2? Where does the sine equal 1/2? Would these be the places? And it's pi over 6 and 5 pi over 6. Now, that's where it's +1/2. Where is it -1/2? 7 pi over 6 and 11 pi over 6. So these are the angles that are going to become part of my answer when I write my intervals. Okay, now I gotta figure out where I'm shading. So remember, this times this is positive, which means they are both positive. That is greater than 0. I'm saying positive, right? Greater than 0. They're both of these guys are greater than 0. Or they are both less than 0. Right? So here I am. These are y values, so I'm looking at this line and this line.
Hello, Cathedral. As we head into the lunch period, let us be mindful.
You guys finish this on your own, see if you can best figure it out. I don't know, I haven't done
Lord,
it
thank
yet.
you for the food before us. Desire to give an offense to